Hello, friends. This is Jim with Science Talk. I want to share with you some interesting news about our moon. Scientists now think that a molten ocean once swirled in the moon's mantle. Now, the mantle is the layer that's found between the crust and the core. So, the churning of this molten ocean, if you will, of magma, which is kind of a viscous molten rock, may have actually created a small magnetic field on the moon. And this magnetic field on the moon might have protected the moon just in the very same way our Earth's magnetic field protects Earth from charged space particles. Measurements of moon rocks brought back by the Apollo astronauts in the 60s and 70s prove that the moon once had a strong magnetic field above its surface. But how the satellite managed to sustain the field is not known. And there's some hypotheses to address that issue. Now, if we look at some of the processes that goes on in Earth, for example, we have all the mid-oceanic ridges and rift zones. And what happens is, as the magma wells up from below, it pushes the plates to the side, and on the other end, the plates go down in the subduction zone where you get your earthquakes and so on. This is all part of the plate tectonics of pushing the Earth's plates over to the surface of the planet. It's a big convection cell that goes on between the crust and the upper portions of the mantle. Now, when the magma comes up, it's hot, but once it hits the ocean floor, the temperature of the seawater is considerably cooler, and it will solidify that magma into rock. As it does so, it locks into place the orientation of certain minerals that are sensitive to magnetism. And the orientation of these minerals helps us to indicate which way the magnetic poles are, which is north, which is south, as well as the direction that these rift zones were orientated. So we can get a lot of paleomagnetism information from looking at these rocks. And basically, the further away from the rift zone that these rocks are found, the older that they are, until eventually it goes to the other side, to the subduction zone, where it goes down into the mantle and is remelted. Then that information is lost. So this is probably a likely scenario or method by which scientists were able to ascertain the fact that the moon had magnetic field. They probably saw minerals within the rocks. And that's what geologists do nowadays. They look at the minerals within the rocks. So, Krista Soderlund, who is a planetary scientist at the University of Texas at Austin, is a co-author of this new study. She basically says we're trying to understand what could cause this rather strong magnetic field. Basically, there are three ingredients required to create a planetary magnetic field. You need a liquid. A liquid could be viscous material, but definitely not solidified. You need some sort of motion of said liquid, and you need electrical conductivity. So electrical conductivity, with electricity, you create a magnetic field, what's called the EM field, electromagnetic field. If you look at power lines, okay, as the energy is being transmitted down the power line, it's also creating a magnetic field. Typically, the magnetic field will be orthogonal to the direction of flow of the electrical field. Orthogonal means at right angles. And so electrical magnetic fields commonly occur together. We can do this with toroids and coils and so on. So now the moon does have a core, but it is small, and according to Dr. Soderlund, it is not sufficient, not capable of creating a magnetic field as strong as what was found in the lunar rocks. The field remained strong until approximately 3.5 billion years ago, then gradually diminished. Now today, the moon does not have a geomagnetic field, other than the extremely weak one created by whatever magnetic forces remain in the crust. No one knows exactly when the large-scale field disappeared for good. There have been various explanations, various hypotheses presented to address this question, and including churning in the core caused by the mantle to some sort of disruption caused by impacts from space debris. However, none of these are panning out. So Soderlund and her colleagues, including Princeton University researcher Aaron Scheinberg and Arizona State University planetary scientist Linda Elkins-Tanton, basically set out to create computer models of the moon's core that would explain the satellite's magnetic field. They could not reproduce what they found using just the core alone, but all of their models resulted in a very hot, viscous condition for the mantle. So that led them to an aha moment, which is basically that melting was the key. So they modified their model to now take the mantle into account. And now they presented the magma ocean hypothesis. So they found that by assuming the existence of a metal-rich, fully molten magma ocean sitting right on top of the core, they could get the geomagnetic field of the same strength as recorded in the actual lunar rocks. And this magma ocean hypothesis, Dr. Soderlund goes on to say, could explain why the moon's magnetic field gradually weakened and vanished as the mantle eventually cooled and solidified after billions of years. So it's basically it would make sense. It's a natural process, a natural evolution of the moon cooling down, and then you could have the sequential type of magnetic field generation, finally weakening, diminishing, and disappearing altogether. And the scientist who first proposed this possibility was Christina Dwyer, and but she was not part of this research, but she proposed this because it brings the driver of the magnetic field closer to the surface. The hypothesis overcomes the problem that the core itself is too weak to create the field. This is a quote from Dr. Dwyer. More measurements and experiments on moon rock conductivity could help show whether the magma ocean idea really fits the evidence. And of course, this leads to other questions. How big's the mantle? When would different portions of it liquid? Okay. If you can answer these kinds of questions, you can get an idea into the overall large picture of the formation of the moon, further tease out the specifics of that, and especially with the current thinking that the moon was formed after a huge impact and it was flung out there and so on, that could help understand better the whole process of how the moon formed and all this other interesting processes going on. So This is a quick little fun story I wanted to share with you, and we'll talk again soon. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.